Hey class, let's go over a couple of examples. This right here is lesson 1.2 density worksheet. So I'm going to go through a couple of examples. I'm not going to do all the problems obviously, but I'm going to go through a bunch of them to make sure that you guys are okay and understand completely what's going on. So the reference table S gives the densities of many elements. Which of the first 10 elements is the least dense? So we go to reference table S. This is the one, the reference table that when I go back through, you'll see it like this is the second to last page usually in that packet of papers that I gave you that has all kinds of information on it. So we go through here. I forgot what the question is. Let me take a look. Reference table S gives densities. Which of the first 10 elements is the least dense? So over here is the density. I'm looking through all of these. Notice the one that's the smallest is hydrogen, 0.000. There's 4 zeros there. This one only has 3 zeros. These have 2. This one here has 3 zeros. None of the rest of them actually come close within like 10 of hydrogen. So it looks like hydrogen is the one that is the least dense. So I go straight to this and I say, obviously it's table hydrogen, I got 4 zeros and then 2, and that's grams per milliliter. Lots of times gases will actually be given density in grams per liter, and what that does then is that changes the actual, so that would move it 1, 2, 3. So you may see something like this also, but not in table S though. Table S gives it to us in grams per milliliter, so that's important. Generally, what phase of matter, solid, liquid, or gas, has the lowest density? Of course, gas has the lowest density because the particles are spaced so far apart, which we'll talk about later on. That would be a good example of a gas. And then the highest density, of course, the highest would of course be solid because they are packed together in a way where they are immovable. So they are like all stuck together at the bottom of a container because of gravity, like that. And that would be a solid for a highest. Lowest, of course, would be for there. Okay, now I'd like to use our time here so I can show you what's going on for number 5. Number 5 is a little bit different because we've done, you've seen regular density problems, but I want to make sure that you understand that units must be the same. So if we're looking for density in grams per cubic centimeter, and by the way, that can also be grams per milliliter because 1 milliliter equals 1 centimeter cubed. I know that's ugly handwriting, but still. So if we have kilograms for mass, I'm going to have to do a metric conversion from kilograms to grams to be able to find out what my answer is. So my mass here is 2.75, that's a 2, there we go. Kilograms, and kilograms to grams means that I'm now, if you remember how to do this, I go from 3 minus 0 because grams is 0 gives me 3, which means I move the decimal place 1, 2, 3 places to the right hand side, which is now my starting amount. So that means that if I'm finding density, density equals mass divided by volume, and that equals 2750 grams divided by what is that? 250.0 centimeters cubed. That means my answer is going to be in grams per cubic centimeter, like that. And whatever we get by taking that divided by that, I don't mind going through it. Let's go through it. There's going to be some questions as far as like how far do we take out, how far do we write down, what is that, 250, yep. Let me just try that one more time. Divided by 250, okay. So I get, that's not right. Hold on, please. 2750 divided by 250 equals 11. Okay, so that would be 11 grams per cubic centimeter. Because I have 3, 1, 2, 3 there, that 0 doesn't count, 1, 2, 3, 4, I should actually do that. And we'll talk more about what that means, 11.0, and why we do that. Okay, so let me just continue on. There's one more thing I'd like to show you. Take a look at number 9. Number 9, some people had some questions on. If we're doing density equals mass over volume, that means I end up like this. I simply fill in the things that we have, which would be 1.64 grams per milliliter over 1 equals, and then what do we need? We have 30 grams. There's my mass, 30 grams, like that. We're looking for the volume. Find the volume. That's volume on the bottom. So that means that when I cross multiply here, I get 30 grams equals 1.164 grams per milliliter over the volume. Okay, and then what I do is I multiply. What am I doing? I'm sorry, guys. Times V. All of this times V, so I divide both sides by 1.164 grams per milliliter. 1.164 grams per milliliter. Okay, and then 30 divided by 1.164 equals, now here's a good example of where to round off at. The answer to this then, of course, will be 25 point, and then I get 77, but because I have 1, 2, 3 places there, I go to 8 here, and that will be in milliliters, like that. And that's how I do that. And you do all B and C exactly the same way. Now let me just take a quick look. Is there anything here? Remember that length times width times height equals volume. Use your volume. For density equals mass divided by volume. That's where that goes there. And then just do the calculation. A cube of gold, okay, volume of a cube is equal to the side cubed. Okay, has a length of 1.5 centimeters. So that would be 1.55 cubed. That would equal your volume. Then you do the same thing we did before. Density equals mass divided by volume. And that goes right there. Okay, this is our water displacement. Make sure that you're watching and using your notes. A water displacement is when you have the object, CT, plus water minus the water. Let me move down just a little bit. Equals the volume of the object. Okay, so you just have to subtract object with the water. That would be, where are we at here? Object with the water looks like this one. And the initial volume of just the water looks like that one. You subtract those two. That gives you the volume of the object, and then you can do your normal. And that goes there. Okay, good luck. I hope you do well.